So, for question 1, we are given 7 components consisting of 4 microchips, 2 resistors and 1 capacitor. Since 3 components are chosen from 7, the total number of possible samples is 7C3. And now we'll have to calculate it using the formula. We construct the formula using the combination principle method. So, to choose microchips, we have 4Cx. For choosing resistors, we have 2Cy. And for choosing capacitors, we have 1C3 minus X minus Y over 7C3, which would be our total component chosen. So, to construct the joint probability table, for X equals to 0 plus Y equals to 0 plus 1 capacitor, it won't be equal to 3. So, first we can put all zeros for the boxes that won't be equal to 3. Next, using the formula, we calculate all valid combinations of X and Y and place the probability into the joint distribution table. So, for example, we have X equals to 0 and Y equals to 2. So, just substitute the number of X and Y. So, 4C0 times 2C2 times 1C1 over 7C3 will have 1 over 35. So just repeat the same method for all X and Y's and just fill in the table. Now let us find the marginal distributions. The marginal distributions of X is denoted by Gx, is found by summing down across rows. So for example, 0 plus 1 over 35 equals to 1 over 35. And for the marginal distributions of Y, denoted by Hy, is found by summing down columns. So for example, 0 plus 0 plus 6 over 35 plus 4 over 35 equals 10 over 35. To determine whether our probabilities and if our marginal distributions of Gx and Hy are right, Gx would be equal to 1 and Hy would be equal to 1. But to find out whether X and Y are independent, we'll have to use fxy is equals to the marginals of X and the marginal of Y. So let's take X equals to 1 and Y equals to 1 for example. 8 over 35 will not be equal to 48 over 245, therefore X and Y are not independent. Now let's find the mean of X and the mean of Y. To find the mean of X, it will be sum of X times their marginal distribution. So 0 times 1 over 35 plus 1 times 12 over 35 plus 2 times 18 over 35 and plus 3 times 5 over 35. And to find the mean of Y, the same thing. So 0 times 10 over 35 plus 1 times 20 over 35 plus 2 times 5 over 35, so we'll have 6 over 7. So from the given joint probability table, we first obtain the marginal distributions by summing the rows and columns. So for example, when X equals to 1, 0.15 plus 0.13 plus 0.15, so the marginal distributions of X equals to 1 would be 0.43. And for Y, for example, when Y equals to 1, 0.15 plus 0.24 equals 0.39, and you can repeat that for all X and Y's. So now, to find the probability of X greater than 2 given Y equals to 2, we use the conditional probability formula. So f X and Y is equals to 2 over marginal of Y equals to 2. So we have 0.22 from here and 0.35 from here, and that would be equal to 0.6286. So for calculating covariance of X and Y, the formula would be EXY minus mean of X times mean of Y. So for mean of X, all X times their marginal distribution, so we'll have 1.57. And for the mean of Y, Y times the marginal distribution, so add them all and we'll have 1.87. So to find the value of EXY, we'll have to times X with Y and their joint distribution. So for X equals to 1, Y equals to 1 times 0.15 for example. So just add all of the X and Y's with their joint distributions and you will get 72 over 25. So to find the covariance of X and Y, the formula, just substitute the values into the formula. 72 over 25 minus 1.57 times 1.87 and you will get negative 0.0559.
Next, I will be explaining question number 2. So marginal densities of X, which is Gx. To find it, we will integrate the function in terms of Y. So we have a lower limit of 0 and upper limit of 4. And then we have the function, which is 1 over 60 times 2x plus y, dy. And then I will bring out the 1 over 60 and integrate the parentheses. And then I will substitute it inside the parentheses. Minus 0, because when you substitute 0 in the parentheses, it will be 0. The final answer would be 2x plus 2 over 15. And the range would be 0 to 3. Next, for marginal density of y, which is hy, we will integrate the function in terms of x. So we have a lower limit of 0 and upper limit of 3. We have 1 over 60, 2x plus y dx. So I will bring out the 1 over 60. Now we'll integrate the parentheses. And then we will substitute it. So the final answer would be 3 plus y over 20. And the range would be 0, y, and 4.
Next question is calculate p x plus y less than or equals to 2. So here I've already drawn the graph underlined for x plus y equals to 2, and the areas I've highlighted in blue is the area of x plus y less than or equals to 2. So to tackle this question, we will do double integrate. I will integrate in terms of x first. So my lower limit will be 0 and the upper limit will be 2 minus y, because since we're integrating in terms of x, we will single out x. So we have x plus y equals to 2, then x equals to 2 minus y. Alright, so first of all, I will bring out the 1 over 60, and then this will be my answer. So now we're going to integrate this equation. For this question, you will have to substitute a 0 in the parentheses, as it will not equals to 0. It will give you a value. So you will have to times back the 1 over 60 that we took out earlier, and you shall get 1 over 15 as your answer.
Moving on to the next question, and number 1 is find EX, EY, and EXY. So to find EX, we need to have GX. So as you can see here, I've already done the GX. GX is basically just the marginal density of X, like we did earlier. So since we are integrating in terms of Y, the easy way for me to say it is the range would be where the Y is in between. So Y is in between 0 and X. So that means the lower limit will be 0 and the upper limit will be X. So you should get the answer for X cubed, and then the range would be 0 less than or equals to X less than or equals to Y. 1, sorry. Then to find EY, we need to find the marginal density of Y. So we are going to integrate this in terms of X. So once again, find X. So the range would be Y to 1. So lower limit Y and upper limit 1, and then we will be integrating in terms of X. And then you should get 4Y minus 4Y cubed, and the range would be 0 less than or equals to Y less than or equals to 1. Okay, then to find EX, so you just basically have to times X with GX. The range would be according to what we find for the marginal density. Here, X times 4X cubed, and towards the end, we will have 4 over 5. And for EY, it's basically the same thing. So basically, you have to times Y with the marginal density of Y with the range that we have gotten for EY. So you integrate it in terms of Y, and at the end you should get 8 over 15. Moving on to EXY. So to find EXY, we need to double integrate. So I am going to integrate in terms of Y first because of the range here. Since we are integrating in terms of Y, it will be 0 to X because the range is 0 less than or equals to Y less than or equals to X. So to integrate Y, the upper limit will be X and the lower limit will be 0, and this will be the answer for the integration in terms of Y. And then we're going to integrate in terms of X. I will bring out 8 over 3. I will expand this, which will get x to the power of 5, and so integrate x to the power of 5, and then at the end you should get 4 over 9. So for the last question, it reads, calculate the covariance of x and y. Are x and y independent? So the formula of covariant is exy minus ex times ey. So since we've already gotten all of those, we can just substitute it, and it shall give you the answer of 4 over 225. So for this one, since we've already gotten covariant, we're going to check it using the covariant. So since our covariant is not equals to 0, then x and y are not independent. Alright, that will conclude our video presentation. Thank you so much. Assalamualaikum.